Hi, we are going to talk about object-oriented programming paradigms. When we talk about object-oriented programming paradigms, we must first understand about the traditional way of programming. Traditionally, when computers were invented, it was looked at as a fast number crunching machine. You can do calculations at very fast speed. So they developed programs like you give some input and then get some output. So the programming paradigm was input, you will have to decide what is the input. You will have to decide what is the output. And then in between, there will be a lot of processing happening. So procedural paradigm was introduced wherein the procedural aspects were introduced and every small activity were converted into small procedures and methods so that we can reuse them. We can call the procedure as and when it is required. So this is how the traditional programming worked. Input, output, and processing. However, as the programmer's world expanded, we started writing programs for very complex real-life problems. Simple business applications such as banking, insurance companies, insurance settlement, and other things, and mark processing systems, library management system, and student, so a lot of things. So where we found that it is very difficult and complex to write the program because the systems are real life systems. In real life, there is nothing called the input, output, the procedure, and other things. So you are talking about a different world. So converting the real life activities into the programming world itself was a tough activity. In fact, at one point in time, we were having somebody called program analyst. So the business analyst, program analyst, technical analyst. So they were not the programmers. They worked on converting the real life scenario into the programming paradigm. At that time, people came out saying that instead of having a rigid boundary on our model with there should be an input, you identify all the input, you identify what is the output required, and then so instead of being rigid, why can't we change the paradigm? Why can't your programming paradigm move into the real life paradigm? In real life, how is life? Look at a bank. Supposing you are interested in developing a software system for banking operations. So in the bank, what are they? If you look at a bank, there is a cashier, there is an officer, there is a bank clerk, so bank staff are there. There are customers, every customer, everybody who is going and doing a banking transaction is a customer. And we do something called a deposit. We withdraw money from there. We have some assets. We have some liability. So in real life, we found that there are some tangible entities. So the programming paradigm shifted into making a software for all the real life entities. That is where people found that we will have something called object-oriented programming. So if a bank has a set of clerks, that is called a class of staff, a class of clerks, CLASS, class of clerks, class of officers, class of customers, class of cashiers, class of deposits. So they are all called entity classes. And supposing you are withdrawing money, it is an activity, it is a method, it's a function. So finally they arrived at, so in the system, there are classes. For example, customer. Customer is a class in which each customer is an object or instance of a class. So they came out with class, objects. If you consider a class, for example, a customer, every customer will have a few attributes. A customer will have a customer ID, a customer will have a name, maybe a first name, a last name. He may have a credit score. So these type of attributes. So depending upon the application, whatever attributes are required, we will define. So that is how we define the class. When you define a class, you can create an instance of the class. For example, a customer, one instance of a customer may be Ramachandran. He may have some IDs, he may have some core and other. For every attribute, there may be some values. So that is how we define a class, object. Then for every object, they may be able to do some activity. For example, a customer can deposit money. So deposit money is a method. It's a deposit. Whereas deposit itself, if you consider the deposit is a class of deposits. Each deposit will have an amount, how much, what is the duration for which it was deposited, what is the date on which it was deposited, and it will also have who deposited. So a customer object becomes an attribute of deposit. So these things are all called the object-oriented programming paradigm. Let us look at it now. Consider a class of employees. So for the class of employees, employee code may be an attribute, the name of the employee is an attribute, designation is an attribute, and how much monthly salary we are paying is an attribute. So this is called a class. In a similar manner, if you define a circle, normally we write programs for finding the area of a circle. For that, for example, circle is a class. You can have several circles. So a circle is a class. What are the attributes? Radius is an attribute, diameter is an attribute, its circumference is an attribute, its area is an attribute. So they are all attributes. In a similar manner, you consider the class, student class. In a student class, a class of students, roll number of a student is an attribute, name is an attribute, his date of birth is an attribute, his mark scored is an attribute, and what is he studying in the college? So course of study is an attribute, and so on. So now when you define the attributes, a class will have several objects, and each object will have the same pattern. The same pattern. Pattern is the set of attributes. All the objects will have the same attributes. Let us consider a simple example. So a class of circles. A class of circle will have so many circles. Circle is the class. So let us see how. So for example, class circle in Python, if you say class circle, it will create a circle template. What are all its attributes? Radius, area, and circumference. We are defining 3 attributes. We are defining 2 methods. One method is to find the area and the circumference. So I am going to call it find area of self. So whenever you define a class, it will have 2 important things. So one is the set of attributes, then the second is the set of methods. So attributes and methods are bundled in the form of a class. So whenever you create an instance of the class or an object of the class, every object will have all the attribute values and the same method behaviors. So that is the way we define the class. Here for circle, we are having 3 attributes: radius, area, and circumference. And one of the method I am going to define def. So we are defining a method, a function for circle class called find area. So whenever you define the method for a class, within the attribute, the first attribute will be given as self. Self denotes the object that you are creating. The object you are creating. Now self dot area equal to, for the circle that you are creating, for the instance of the circle that you are creating, area equal to math dot pi star self dot radius star self dot radius. So pi r square If radius is known, then find area method will find out area, and the next line is about circumference. So what is the behavior of the find area method? Find area method will calculate the area and circumference provided the radius is known. Similarly, another method I am defining, display circle of self. Self is the instance. So when you call this method, print radius and then the radius, print circumference, area, print the area. So it will print. So when you say display circle, it will display the values of radius, circumference and area. So we have two methods and three attributes for this method. Do you know what happens? When you say x equal to circle, an empty template of a circle is created and it is given a name x. So x points to a template called template of circle, that which will have radius, circumference and area, but everything is empty. Nothing has been assigned. Similarly, when you say y equal to circle, another template of a circle is created and y will be pointing at that. When you say z equal to circle, there is another template created. So now three templates have been created. One template called x, another template called y, and a third one called z. All of them are circle templates. So a circle template will have attribute values for radius, area and circumference. So once that is done, I am writing x dot radius equal to 3.5. So x is pointing at one object, For that object, radius I am assigning as 3.5. In a similar manner, for the y circle, I am assigning radius equal to 1.5. For the z dot radius, I am assigning 10. So now there is a template called x, there is a template called y, there is a template called z, and 3.5, 1.5 and 10. So this is how it appears. Now I am calling x dot find area. So the find area method will be called and the calculation will happen, calculation of radius and circumference finishes. Then y dot find radius, the radius and circumference will be calculated for y. Similarly z. Once all these things are done, we can call the display circle method. I can call display circle of x dot display circle, y dot display circle, z dot display circle. That will actually print all of them. We are going to see here. Now let me run it. I am running it now. Look at it. See, radius. So for the first circle, so x dot display circle, it prints radius equal to 3.5, circumference equal to 21.99, area equal to 38 point. Then y dot display circle, it is printing radius equal to 1.5, circumference equal to 9.4, area equal to 7.0. Then calls z dot display circle, radius equal to 10, circumference equal to 62 point something, area equal to 314 point something. So that is how it calculates all these things. Actually, I want to tell you, in Python, even the attributes need not be defined here. Attributes, even if you don't declare, it will take it up as and when it is assigned. So the attributes need not be declared at the beginning. So with 0 and other things. Even this will work. I am going to run it again and show you. Same thing. See, if you want some in the print statement, actually you can even make it whenever you begin the first one, you can have a \n. In that case, at least there will be a gap between the first circle, second circle and the third circle. So these type of things can be done.